I want to show you the syllabus. Okay, that's A, B, and C. These three near shortest, as I told you before. So first for shortest, you need the relative energies of S, P, D, and F. So what do you think that which one having the lowest energy from S, P, and D? S having lowest energy, good. Then P and then D. Then what do you know about the principal quantum number? N1, N2, N3, and N4. We have four energy levels, or you can call principal quantum shell or numbers. What is the difference between 4s and 4p orbitals? Which one having the lowest energy? 4s having less than 4p. Good. So these some reasons are there. You need to understand that which one having the lowest energy, especially S and P and D. Second things, you must know the principal quantum number. So from N1 to N4, we can call energy level or we can call principal quantum number, shell. Now, and then we must know what is the difference between the 4s and 4p orbital. The difference is only energy. 4s having less energy than 4p. Then for first objective, you need one thing for calculation, that how many electron in N1, how many electron in N2, N3, and N4. For that purpose, what you will do? 2n square. 2n square. N number will be given to you. That maybe n is a quantum number like N2. So 2n square. Your formula is 2n square. So substitute the value of n, then calculate how many electrons are there. Come on, the second part B. Describe and sketch the shape of sp orbitals. This page number 31 from your chemistry book, S and P. You can see what is the shape of S and P as spherical shape. As spherical shape. These are the three axes X, Y, and Z. So this one is S orbital. S is a spherical shape. And P we can divide into more three orbitals. Px, Py, and Pz. You need these all. How to draw the shape for Ps, for Py, and Pz. Page number 31. On the top, there are three shapes given. Px on x-axis, Py on y-axis, and Pz on z-axis. This one y, and this one x-axis. So we have three: Px, Py, and Pz. Three orientation. You can see page number 31. Clear about the shapes? Any question, please? Came late. Page number 31. You open? Yes. On the top, three shapes are given to you. This is your objective B. Objective, you can see. That is 2s. Any s having spherical shape. 2s, 3s, 4s, whatever, spherical shape. Close the door. Spherical shape. Understand? And P, for P we have three: Px, Py, and Pz. How to draw the shape is very important for exam. Now, yes. Yes. Sorry, I did not get your question. We will not draw for 3px, 2px, 2py, 2pz. For 2p, not 3. Okay? Now, the third one is state the electronic configuration of atom and ions given the proton number and charge using this 1s, 2s, 2p, 3s, 3p, 4s, and 3d. You have to use this order, and draw the electronic configuration. Maximum how many electrons we can fill up in S? 2. In P? 6. In D? 10. So you will check the atomic numbers. With atomic number given, suppose you have magnesium Mg. So Mg atomic number is 12. Atomic number 12, Mg. Atomic number 12. So how you will fill up? Please, can you call with me? Like total we have 12 electron, is it? So in 1s how many? 2. 2s 2. 2p 6. 3s 2. So 2 plus 2 4. 4 plus 6 10. 10 plus 2 12. So magnesium having atomic number 12. So in this way we can fill up 1s2, 2s2, 2p6, 3s2. If more electron, then we will enter next shell. Understand? Till 3s we do. If there is electron, then we will enter into 3p, then 4s, then 3d. Understand? Till 4d. Till 3d for you, till 3d. Not more than that. I am going to repeat order again. Just concentrate. 1s, 2s, 2p, then 3s, 3p, 4s, 3d. That's it. So the electronic configuration may be atoms given or maybe in ions given. Ions mean like magnesium plus 2. That is an ionic form. But only magnesium, nothing written about magnesium, 0. It's mean atomic form. If I write here magnesium plus 2, this is ion. Magnesium ion. Understand? If without positive sign, nothing written or written 0, it's mean atomic form. Okay? So here magnesium plus 2. Plus 2 mean how many electrons they are going to release? 2. So when they release 2 electrons, how many left? They release this one, these 2. Okay, how many left now? 10. So what is the electronic configuration of a magnesium? 1s2, 2s2, 2p6. 1s2, 2s2, 2p6 only. There is 3s2, but when we write here plus 2, it means we remove the electron. Plus 2 means electron released from the outer shell. Understand now? Okay. These 3 objective A, B, and C in your short test. Any question about this? Any one of you, please? Ready for that? You have Thursday short test, is it? Sorry? This you want to write or objective you want to write? Okay, right. Open the notebook, whatever you want, write. I uploaded already this syllabus. You need to check where is the unit. Page number 11. This syllabus on your platform. When you open page number 11, objective number A, B, and C. These 3 in your short test. You want to write? Hamid, also you can write, please. You want to write A, B, C, you can write on your notebook because these 3 in your objective.
Okay, so, okay.
Okay, Zoom. I will. Just tell me what you want. Yes. Name of unit is atomic structure. Clear now? Hamesh? Huh? Sit here. No, it's okay. So A, B, and C. A, B, and C only. A, B, and C. You want to write now, it's okay. Otherwise, from platform, syllabus already I uploaded, page number 11, unit atomic structure, first three objectives in your short test A, B, and C. Who? Why? Uh-huh. So it's okay if you copy, huh? No need. No need to write again. Those you can download from the platform and you can see. It's okay, no need to write. That's why I call you page number 11 from the syllabus, unit atomic structure, the objective A, B, and C. That's it. This already is there. Quickly because he's online actually, Hamad, so we have to. Hamad, please write these three objectives.
Okay, Mr.
You can copy these. In between there is a left the space. Later when I show you the PowerPoint slide, you can write the message. At least two lines for first three, and last one we will write more actually. I hope you finish, is it? Amish, Fahad, Mohammed. Quickly. Muhammad, what you write spelling of your name?
Muhal.
Okay. Because your name not in D here. I have the list of.
Online. Hassan said they were changing, but it didn't change.
He did not change. See, Hamad bin Jamal Al Maskri online, he is there. But your name is not there. Yeah. I write with me, no problem, because I know you. Fahad, finish? Last one, just write electronic configuration and after that write the order. Electronic configuration, write EC, then write the order of that. The third A, B, C. How many you finish?
Yes, Mr. I finished.
Okay, for last this part C, under this you have to write, I will call you like this, you will write the order. Okay, right now 1s,
Okay, 1S,
2s, 2p,
2S, 2P,
3s, 3p,
3S, 3P,
4s, 3d,
4S, and then 3 what?
3d.
3D.
Okay.
Okay.
This is the order that how to fill up the electron. That's it. Okay.
Okay.
Now I'm going to show the other screen. You can see today our topic. Ionization energy. Can I start now? I will not write.
Yes.
You can write later. Okay. Ionization energy and atomic radius. Two topics left, and we are going to cover both now. A very simple topic and very easy actually. Ionization energy we will represent sometime I dot E, capital I dot capital. These are the objective. Number one, explain and use the term ionization energy. Yes? Yes, Hamid, any problem?
No, Mr.
Okay, please listen carefully. So these are the objectives what we are going to learn. First, you need to define what is ionization energy. That here I wrote first one, ionization energy. So you need to define what is this. Then we have explained the factor. The last one actually, factor affecting on ionization energy. But before this, we must study the types of ionization energy. First definition, then we have two, first and second ionization energy. Then we will study the how many factors those will affect on ionization energy, and there is a part E, last one, there is trends in periodic table. Trends mean change from top to bottom, from left to right in periodic table. That what will happen, either it will increase or decrease, that's it. Okay, so see this one. What is ionization energy? Ionization energy is measured to amount of energy needed to remove electron from an atom. This is the definition. I already uploaded, okay? So when you just open and write on your notebook later, try to understand better now. So we need energy, amount of energy to remove electron. Like any element, like magnesium, Mg, or just write sodium because we are going to remove one electron, sodium in atomic form. We are going to remove one electron, total sodium, 11 electron in sodium. We are going to remove one. So the amount of energy required to remove one electron from an atom we call ionization energy. Very simple amount of energy to remove one electron, that's it. So we are going to, how we will remove, see here, Na, it will become +1. Why I write +1? Because we remove one electron, that's why. You can see this one. They took here the example of calcium. So first, what is first ionization energy? When to remove first electron. Second ionization energy when you remove second electron. That's it. So type first and second mean when you remove one electron, you can see here when you remove one electron, this is the gaseous atom. You are going to remove one electron from calcium. So when you remove one electron, this positive written one or not, it's mean one. So positive and then plus E negative mean electron. So when you remove one electron, the amount of energy needed to remove is plus 590 kilojoules per mole. This amount of energy required to remove one electron we call ionization energy. The amount of energy needed or required to remove one electron from a gaseous atom, because this is written in G form. So we call ionization energy, and if you remove one electron, so first ionization energy. So we need 590. Plus sign indicate you need energy, required energy, absorb energy. Then come on the second one, second ionization energy here. In second ionization energy refers to removal of second electron and so on, maybe third ionization energy, fourth ionization energy. It depends that how many electron you are going to remove from an gaseous atom. So the only need to understand here the concept is first ionization energy, we remove electron from gaseous atom. Keep in mind here, gaseous atom. But second ionization energy, we are going to remove from gaseous ions, because positive here. It's mean from calcium we remove one electron, we are going to remove again from calcium, from same species. First we remove one electron, we are going to remove second electron, but from same thing, same species, same ions, that is calcium plus here. We already remove one electron from here, Ca plus 1. So from same ionic form of calcium, calcium ions, we are going to remove another electron. So you know, if I have the two marker and I need both, if I give one to Hamesh and he also called, please teacher give another one. So first I can give because I have one for writing. Is it? I can give him one marker, but he needs second one also. So for me it's very difficult. If I hand over to him, then how we will write on the board? Is it? So you understand this? It means second ionization energy is more difficult to remove electron as compared to first. So I have two marker, one I can give, one I can write. But if I want to give the second one, it's for me is very difficult. Why? Because I want to write something. You understand me? So look at the energy here. When you are going to remove another electron from calcium ion, then it will become plus 2. So plus 2 mean how many electron now we remove? 2 electron. First in the first ionization energy, second now we will remove, so it's plus 2. Look at the amount of energy, it's 590 and 1150. What do you think? It's double or triple or double? So this, you need this concept that which amount of energy is greater, first or second? Second amount of energy is higher than first. The reason is only there because we are going very difficult to remove electron from Ca plus. So it's mean we need more amount of energy to remove. First 590, second 1150. So if you want to remove second electron, you need double amount. So what do you think if we want to remove another electron from this, mean third electron? What do you think? What will happen with the amount of energy? It will become triple, yes. So more electron you need to remove, you need high amount of energy. So because in your syllabus first and second, so just keep here this concept that amount of energy is second is greater than first. You can say the double of first. Yes.
What's DHI2? What does I mean?
This one?
Yes.
Ionization energy 1, ionization energy 2. Okay, I just write shortcut. Ionization energy 2, this I1 mean ionization energy 1. Okay, Salim? Clear now what is first and what is second? When you remove first electron, when you remove second electron. What is the difference between first ionization energy and second ionization energy? Is difference the amount of energy. Second ionization energy you can write like this. Second ionization energy is greater than first ionization energy because it's difficult to remove electron from second from ionic form as compared to this atomic form. Yes.
So this 590 and 1150 stable for every other element.
No, not for all, for only calcium. Different atoms, good question. Different atoms, they need different amount of energy. Why? Because calcium atomic number 20. If we are going to learn about the sodium atomic number 11, we have less electron. Here 20 electron, more electron. So it's depend upon which atom you are going to remove the electron. Clear now? Now, factors affecting the ionization energy. That those they are responsible to change the ionization energy. Either it will become increase or decrease. So first factor is charge on the nucleus or number of proton. Charge on the nucleus or number of proton. What do you think that if charge on the nucleus is greater, you need high amount of energy? Okay, why? See, we study here calcium plus 1 in first ionization energy. Here we study calcium plus 2 in ionization energy. Understand? So here plus 1, here plus 2. Charge increase or decrease? Increase. If charge increase, what do you think? You need high amount of energy? Understand? The greater the nuclear charge, the higher the ionization energy. How many total?
9. Still 2 options.
Which one is?
After Rahim Khan.
Abdul Rahim and Abdullah. Clear now? This point, if more charge, here plus 1, here plus 2, if more charge, ionization energy will become greater. Number 2, the distance between nucleus and the outer electron, or you can see the size of an atom or ion. If distance between nucleus and outer electron, greater the distance between the nucleus and outer electron, the lower the ionization energy. Why the lower ionization energy? See, this one is the nucleus. This first shell, second shell, fourth shell, or you can say energy, first energy level N1, N2, N3. If electron present here near to the nucleus, is it? But if electron present in third shell, our energy level N3. So the distance between nucleus and outer shell is greater or large. If distance large, forces are weak. Like two magnets is closer to each other, they have a greater force. But if they have a distance between each other, no force, are very, very weak. Is it? So in weak forces, we need less amount of energy to remove the electron. That's why they wrote here, if distance is greater, then ionization energy is lower the ionization energy. The second factor. Third and last one is shielding or screening effect by the inner electron. The greater the shielding effect, the lower the ionization energy. How you will understand the shielding effect? You know that we have 4 energy levels, N1, N2, N3 and N4. Electron present in N1 also, here also electron present, N2 also electron present, N3 also electron present. You know what is the charge on electron here? Negative. What is the charge on electron? Here, negative. So negative and negative, they repel each other or they attract? They repel. So if repulsion is more, because the same charge, if more repulsion between inner electron and outer electron, understand? Electron present inside mean N2 and electron present in N3. Both are electron. They have negative charge. Their both repulsion is greater there. Is it? So if more repulsion, because same charge, repulsion actually we call shielding or screening effect. If you want to know what is shielding and screening effect, the repulsion between inner and outer electron. If repulsion is greater, it means we need less amount of energy. So only in first, if more charge, high amount of energy. But others we need less amount of energy. Are clear about the factor affecting on ionization energy? There are three factors. First one is, I'm going back for revision. First one is charge on nucleus. If greater the charge, higher the ionization energy. Second, distance. If larger the difference, ionization energy will become low. And third one, if more shielding effect, mean more repulsion there, ionization energy will become low. That's it. Okay. Trend. Trends in ionization energy down the group mean from top to bottom. Trends mean change from top to bottom when we are going to travel within a group. And if from left to right within a period or across a period, they use these words across a period or from top to bottom within a group. So you need just that it will decrease or increase. So what will happen if the ionization energy within a group, it will decrease. Ionization energy will decrease. You need this one. Ionization energy decrease from. What about the second and third? See the reason why it will increase, then you will get the answer. This is because the atomic size increase. Second, outer electron also experience a greater shielding effect with the inner electron. Repulsion is more. Effective nuclear charge is less. Mean if +2, it will become +1. So first things, when we are going down, the atomic number increase. You will get the answer now. When we are going down within a group from top to bottom, atomic number increase. When atomic number increase, number of shells increase. If more shells are there, so the distance between the nucleus and outer shell is large. If distance large, what do you think? How much amount of energy you need to remove the electron? Low. That's why it will become decreased on the group. Clear now this first one? So within a group, what is the trend? Decrease. Now across a period, from left to right, in periodic table from left to right, increase. From left to right increase, the reason the number of proton in a nucleus increase by 1. If number of proton increase, therefore the nuclear charge increase. You know, if nuclear charge increase, +1 to +2, +3, +4, if charge increase, you saw before in factor affecting, you saw before there or not, when nuclear charge increase, ionization energy increase. So why, if there is a reason why ionization energy increase from left to right? Because nuclear charge increase. That's it. You just keep in mind this statement, nuclear charge increase. Because nuclear charge increase. This last three words. Nuclear charge increase. Understand? So from top to bottom decrease, from left to right increase. See now, this graph is very important, please. This graph may be during the exam, final exam now, because this exam only first 3 objective, this graph will come. Just suppose, if this graph will be there, you need to explain what. In this graph, you can see the zigzag line. Yes. Like see, here the first ionization energy on the y-axis, and on x-axis the number of proton. Hydrogen and helium, if you compare these two, we have many, but some reasons are here, not more than that, so we will compare only first magnesium and aluminum, phosphorus and sulfur. Only magnesium and aluminum, phosphorus and sulfur, we are going to compare only these. Phosphorus is greater than sulfur. Here magnesium is greater than aluminum. So this you need to explain why this will become here magnesium and aluminum, suppose. Magnesium and aluminum. The drop between magnesium and aluminum. I am going back, you can see magnesium and aluminum. Beryllium and boron, they wrote the next slide. Magnesium and aluminum, then we will study others. So see here, why magnesium is greater than aluminum. The Y first ionization energy of magnesium is greater than aluminum. So this is because of fifth electron in boron, or you can see here because the electron present in magnesium located in 2p subshell, or you can say 2s subshell, which is slightly further away from the nucleus. So if away from the nucleus, the forces are weak. If forces are weak, we need less amount of energy. So you can say about the aluminum, in electron present in aluminum and its outer shell are further away from nucleus. If away from the nucleus, so we need less amount of energy. That's why aluminum having lower energy as compared to magnesium. What is the reason? Reason is this one you saw before. The distance between nucleus and outer shell is large. If distance is large, forces are weak, we need less amount of energy to remove the electron. If distance is less, forces are strong. With strong forces, we need more amount to remove the electron because they tightly hold there. But if the distance is large, forces are very weak, so it will not stay for a long time. You can just produce the energy, then it will become easily to release from that shell. Understand? Okay, now next please. Phosphorus and sulfur are nitrogen and oxygen. Phosphorus and sulfur. So you can go back, which one is higher? Phosphorus, P, and then S. So about S, sulfur. This is because between electron being removed in oxygen is from the orbital which contain a pair of electrons, and the extra repulsion between the pair of electron. Extra repulsion means, I told you, we have shielding effect. So if more shielding effect, what about the ionization energy? Lower. That's why sulfur having the less energy as compared to phosphorus. Clear now? Any problem about the ionization energy? This already I uploaded, you can see from your platform. Now, our next topic is atomic radius. Variation in atomic radius and ionic radius. Variation means change, good. Or you can say the trend in ionization energy. Like that we study here also. Variation in atomic radius and ionic radius. What do you think? What is the difference between atomic radius and ionic radius? Atomic radius, if you draw the electronic configuration for atom, and if you draw the electronic configuration for ions, what is the difference between both? For atoms, you need to draw complete shell, is it? Complete electron. But for ions, you need to remove electron, is it? Like +1, +2, is some electrons we remove, then the size of atom, what do you think? It will increase or decrease? See, original, I will give one example. We have one atom, sodium. How many electrons? 11. So in first shell, how many electrons? 2. Second shell we have 8. Third shell we have 1. Total it will become 11. But if you want to write for sodium ions, that is for atom. Try to understand. This for sodium ion.
Yeah.
+1. It means how many electron left? No. +1 means how many electron left out of 11? 10. Good. First shell, how many electron? 2. Second, how many? 8. You need to draw the third shell? No, because we remove the electron. So here, how many shell? How many energy level in atomic form? 3. The distance between nucleus and outer shell is large, but here distance between. So in ionic, size increase or decrease now? Decrease. Understand? In atomic size, in atomic form size increase, but in ionic form size decrease. If positive. If positive, positive means removal of electron. But in case of another example, here Cl, chlorine 17. In first shell, how many? 2. Good. Second, third shell, 7. Excellent. But here chlorine 17 -1 charge. -1 means extra electron. Again 2, 8 and 8. How many electron now? 8. Before it was 7. -1 means addition of electron. Negative means an extra electron got. Gain of electron. So now it will become 8. If 8 electron, then size the shell will be same. But you can say if addition of -2 here, then we have to enter another shell. Understand? Then 8 complete. But if -2, then we have to draw another shell, is it? So if negative, anionic, the size increase. But if positive, we call cationic, like C. C-A-T-O-N-I. Cation. Cationic. This one, anionic. They'll use the term. You can see there. But you understand that in atomic form, size increase, but in ionic form, size decrease. If positive, if negative, size increase. This is your periodic table. We are going to learn about their size of an atom. See their atomic radius first. The distance from nucleus of an atom to the outermost electron. So when you go down, what happened with this blue color size? Increase. But from left to right, almost same. It will become, or you can say that decrease but little. Understand from this? So you know the trend now. From top to bottom what happened, from left to right what happened. See the trend. As you go down in column or in group, atomic radius increase, but as you across the period from left to right, atomic radius decrease. This you need only. That what will happen with the atomic radius from top to bottom, from left to right. Clear now? You can see here atomic radius trend. This is more explanation. Later you will study. From this, it's very clear for you the size of an atom, distance from the nucleus and outermost electron. See lithium, sodium, potassium, rubidium, cesium. When we go down, their size more, but from left to right, take any example like lithium, beryllium, boron, until neon. From left to right, size decrease. So you need only that what will happen from top to bottom, from left to right. Read carefully this graph, please, and then you can predict that either it will become increase or decrease. What do you think from lithium to fluorine in period 2? And what do you think from sodium to argon, potassium to calcium? It means from left to right, increase, but from top to bottom, decrease. Ionic radius. Before it was, what is that? Maybe just, I think.
Ionic radius.
Wait.